So we are back to our demand estimation topic under managerial economics. So this is basically our second question we are solving. So we have our variable to be intersect price of bedrock fertilizer PX, price of cereal fertilizer PY, per capita income I, advertising A, R squared, adjusted R squared, F statistics. We have our parameter estimates, we have our standard error. Let's move on to the first question, which is the A. Write down the estimated demand equation for your firm's product. So we have the equation to be y naught is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. So now we want to find the estimated demand equation from this table. So this is how we do it. Remember that another name for intercept is the same as well. Intercept is the same as constant. So it represents the beta naught. So in place of the beta naught, we put minus 144. So minus 144. So the next one, beta 1, minus 2.5 px. Plus 1.25 py. Plus 0.20 pi. Plus 0.068. So basically, this is what they were asking from you. Write down the estimated demand equation for your firm's product. So this is the estimated demand equation. Demand is equal to minus 144 minus 2.5 px plus 1.25 py plus 0.20 I plus 0.068. So let's move on to the second question, which is the B. So the view question, what is the relationship between bedrock fertilizer and cereal fertilizer? So in our previous lessons, we identified that whenever the question states that what is the relationship, we are referring to substitute or what complement. Whenever it states that what type of good is this, we are referring to what normal good and what inferior good. So in a B, what is the relationship between bedrock fertilizer and cereal fertilizer? Are you key? So they are talking about either was substitute or complement. And we know that with a substitute or complement, so they all fall under price of other related goods, which is either with the price of other related goods, we use either PY or PZ. So we have substitute, we have complement. With a complement, it has a negative coefficient, substitute positive coefficient. So we know that with the other related goods, it's denoted by what? Either a capital, sorry, either PY or PZ. So we come into the table and set for either PY or PZ in the table. Then we check the sign attached to that number. If it's negative, then it's what? A complement. If it's positive, then it's a substitute. So let's check. Do we have PZ? No, we don't have PZ. So let's check for PY. So you have PY, price of cereal fertilizer, PY. If it's negative, it's complement. If it's positive, substitute. So it's what? Positive 1.25. So the relationship between bedrock fertilizer and cereal It's positive, so substitute good. Because it has a positive coefficient. A positive coefficient. Coefficient of PY. Let's have the relationship. Substitute or what? Complement. What type of good? Normal good or inferior good? So you come to the table and check whether the PY or the PZ. If it's negative, then it was complement. If it's positive, then it was substitute. So there is the PY. It's positive, 1.25, so it's a substitute good. So the relationship between bedrock fertilizer and asasera are substitute goods because it has a positive coefficient of PY. So move on to the next question. See question. What type of good is bedrock fertilizer? And I say around that, but the type of result, normal good and inferior good, relationship, substitute and what complement. So now, what type of good? We are referring to what? Either what the normal good and inferior good. And the normal good and inferior good fall under what? Income. So we have this in the income. So in the income, we have normal good. We have inferior good. If it's an inferior good, then it's negative. If it's a normal good, then it's positive. Okay. So now, we know that with the income, it's denoted by either a capital I or a capital N. So you come and search in the table whether we say a capital I. If it's positive, then it's what a normal good. If it's negative, then it's what an inferior good. So we don't have N here. So we search for the other variable, which is capital I. So we have income here. It's positive, 0.20. If it's positive, then it's a normal good. If it's negative, then it's what an inferior good. So it is a normal good. Therefore, bedrock fertilizer is a normal because it has positive coefficient of I. So we are moving on to the next question, which is the D part. So in question D, test for the significance of the estimated coefficient of the explanatory variable at 5% significance level using theta equals what 2. So with this, we are not going to use the 5% to calculate for what the theta. Are you doing? We are already given the theta. So the first one, so testing for so the first step, so step 1. You state the hypothesis. So you have hypothesis, which is H2. You have H2 is equal to determinant, which is equal to what? 0. You have alternative hypothesis. Which is HE. So HE determinant is not equal to 0. So step 2. Level of significance. We're giving level of significance to be 5%. That's it. 0.05. Step 3. Find the F statistics, which is T cal or T stat to be equal to our coefficient or parameter estimate over standard error. So we have 0.4. Find the critical values. So with the 0.4, okay, so let me start. Testing for significance level. First, step 1, state the hypothesis. Now hypothesis denoted by what? If the subscript was 0. So now hypothesis, it said that beta not equal to what? 0. Now the assumption based on now hypothesis. With the alternative hypothesis too, if it said that beta not is not equal to 0. With the now hypothesis, there's what? No relationship. With hypothesis, there's what? A relationship. Step 2, level of significance. We're giving alpha to what? 5%. So 0.05. Step 3, find the F statistics. Either it's noted by what? Your T calculated or your T stat, which is equal to your coefficient or your parameter estimate over what? Your standard error. 0.4, find the critical values. But this is where we find what the level of significance is divided by 2. And also find the degree of freedom, which is n minus k minus 1. Here lies the case, what we are going to find is already given to us as what? The theta. Because with the critical values, we get what? Significant, which is we divide by 2. They also find the degree of freedom. So with the degree of freedom, you add it to what? The level of significance, they get what? The theta. But with this particular question, we already given the theta, so we just put the theta here. So theta 2. So we are moving on towards the 0.5, which is for the decision rule. So 5. Decision rule. So we have variables. Another name for parameter estimate is what? Coefficient. So let me use coefficient. Let me do this way for parameter estimate. The next thing is what? Standard error. So we have our T curve or T star. We have our T dot. So the first one, PX. The second one, PY. Income. E. So with the PX, what was the coefficient of PX? Minus 2.5. Minus 2.5. What was the standard error? 0.98261. PY 1.25. 1.25. Standard error 0.0242. Income 0.20. Standard error 0.3685. Advertising 0.06. Standard error 0.0224. So we know to do for us to be able to calculate for the T curve or the T statistics, we will divide what? The coefficients or the parameter estimate by what? Our standard error. We have PX, coefficient, over standard error. What's the coefficient of PX? Minus 2.5. Standard error 0.98261. minus 2.54. Meaning that the pH, the T car is minus 2.54. Minus 2.54. Okay. So we are moving on to PY. PY coefficient 1.25. Standard error 0.0242. So the PY 51.65. Moving on to the income, the I. Coefficient 0.20. Standard error 0.3685. 0.3685. So income 0.54. You are fine for the advertising. So coefficient 0.06. Standard error 0.022. Basically, we are done with what? The T car and the T stat for all the variables, PX, PY, income, and advertising. So with the T tab side, if you are not giving them, you calculate using what the 5 steps. But in this instance, we are giving T tab to 2. So the whole of this side is 2, 2, 2, 2. So with the decision, we are going to compare this side. We are going to compare the T car or the T stat towards the T tab. So, so this decision, if your T car, absolute T car, is greater than your T car, we reject the now hypothesis. Which is a false statement. Making it significant. So again, if your T car is less than the T car, we fail to reject the null hypothesis. Which is a true statement. Making it insignificant. So now let's test. For the first one, px. This px. Okay, so you compare. You have px. There's the T car for px. There's the T car. So if your T car is less than your theta, we reject the null hypothesis. Okay. Someone asked that, okay, why do you have this side? You have what? Minus 2.50, but you are saying that with this side, we reject the null hypothesis. Whenever you are dealing with theta or t star, you always pick absolute values of what? The number. So if you are picking an absolute value of negative 2.54, there's the absolute. When the absolute value comes this side, it eliminates the negative, it becomes what? Positive 2.54. Are you okay? So with this side, we are going to eliminate the negative sign based on what? The absolute values of what? The t car or the what? The t star. So now we have 2.54 instead of what? The negative 2.54. So now 2.54 is greater than 2. So with this side, what do? We reject the now what? Hypothesis. Because t car or the t star is greater than the theta. Theta, the absolute values of theta is greater than theta. So the next one, Dy. We have 51.65 is greater than 2. So this side we reject the null hypothesis. So with the first one, PS, we did a null hypothesis, which is t car is greater than theta, making it PS, we reject a null hypothesis, which means t car is greater than theta, making it significant. So Py we have 51.65 is greater than theta, so we reject the null hypothesis, but it's significant. Theta is greater than theta. So move on to income. So with the income, we have 0.54. We have 2 here. 0.54 is less than the theta. Or we see the theta is greater than what? The theta for what? Income. So we just say we are not going to reject the null hypothesis, but rather we fail to reject because theta is greater than what? Theta. So with the income, we fail to reject. To reject the null hypothesis, which is our theta, the absolute values of our theta is less than our theta, making it insignificant. You are left with the last one, which is the advertisement A. Okay. So the advertisement, we have 2.68. 2.68 is greater than what the theta. If your theta is greater than your theta, we reject the null hypothesis. If your theta is greater than your theta, we fail to reject. So with this side, we are going to reject the null hypothesis because 2.68 is greater than 2. So with advertisement, we reject the null hypothesis. Which is our theta, absolute values of our theta is greater than our theta, making it significant. Okay. So with the decision rule, that's how we do it. Px is greater than your t cap for Px is greater than theta. So we reject the null hypothesis, which is what? Significant. With the py is greater than your t cap, so we reject, making it what? Significant. With the income, it's less than your t cap, so we fail to reject. With the advertisement, it's greater than what? Your t cap, so we reject the null hypothesis. So we can conclude that. So with the conclusion. All our explanatory variables are, sorry, let me use the conclusion. The level of significance given in the question was what? 5%. So 5 minus 100 is what? 95. So we are 95% confident that all our explanatory variables are significant. Then you put in what? All the significant variables. So Px is significant, Py is significant, A is significant. So Px, Py, A, with the exception of income, which is insignificant. Income. Which is insignificant. So we get D, that's what we're asking of S. So you conclude, we're giving 5% significance, so we subtract it from 100. We have 95%. So we are 95% confident that all the explanatory variables are significant. They are significant. Px, significant. Py, significant. A, significant. So we are 95% confident that all explanatory variables are significant. Dx, Py, and A, with the exception of income, which is insignificant. That's income. So we are done with the D. Okay. So with the A question, interpret the coefficient of the significance of the variables. So based on your decision rule, the variables you have to what? Significant. You are going to interpret only those ones here. So we had Px to be what? Insignificant. So we had Px to be significant. We had Py to be significant. We had I to what? Insignificant. We had A, which is advertisement, to what? Significant. We are going to interpret advertisement, Py, Px, with the exception of what? Income, which is what? Insignificant. So interpretation of significant variables. The first one, Px. The value of Px is what? Negative 2.5. Negative 2.5. So a unit change in the independent variable, which is the Px, will lead to a change in the dependent variable by 2.5 units. Remember, in our previous lessons, we explained when it's negative, how we do it, and when it's positive, how we do it. If it's negative, by 2.5 units in the opposite what? Direction. If it's positive, in the same direction. So by 2.5 units in the opposite direction. Opposite direction. All things. So the next one, PY. PY was 1.25, this side. The coefficient of PY is 1.25. So a unit change in the independent variable. Which is PY, will lead to a change in the dependent variable. Which is demand by 1.25 units. It's positive, so in the same direction. All things being equal. So you do same for what? Advertisement. Advertisement is it's positive, so the same approach like this. Are you doing? If it's positive, you use the same understanding. You need change the independent variable, which is PY. Will lead to a change in the dependent variable by 1.25 units. It's positive, so in the same direction. All things being equal. If it's negative, in the opposite direction. All things being equal. So basically, we are done with the E. With the advertising, you guys can explain based on this. We move on to what? Okay. So with the question A, tell me the quantity of bedrock fertilizers bought by consumers. So you have the demand funds to this. So you are going to look for what? The explanatory variables or the regressions in the question. Then we substitute them into what? The demand funds to get what? The quantity. So now suppose 2 bags of bedrock fertilizer is sold for 40 cedis. So there's 2 bags is sold for 40 cedis. A bag of asasira fertilizer is sold for 40 cedis. Income was 750. Advertising 800. Are you kidding? Whenever you are dealing with demand estimation, you want to get the actual quantity. You're supposed to give in, let's say PY is 40 cedis or PY is 30 cedis. Whenever you are giving it in this format, 2 bags is 40 cedis. We want to get the actual price. So we divide the 40 by what? 2. Then we get what? The actual price we are going to get. It becomes 2 px is equal to 40. 2 goes here. 20. So px 20. So it's demand function. QA. Minus 144 minus 2.5. px 20. 1.25. py 40 plus 0.20. Income 750 plus 0.06. Advertising 800. So when we sum them all together, we are going to get 54. So it's quantity, so 54 units. Anything. So basically, if that's what they're asking from you, determine the quantity of bedrock fertilizers bought by the consumer. This is how we do it. Always check this side. If it's per unit, they use the actual price. If it's they are trying to say that okay, 4 bags was sold for 80 cedis. You are not giving what the actual price. So you divide the 80 by what? The 4, then you get what the actual price. In this instance, we're giving what 2 bags of 40 cedis. So we wouldn't use the 40 straight into the equation. You get it from. We divide the 40 by 2 to get the actual price. So that's how we solve the F. So we move on to the G. with a J, estimate the own price elasticity of what? Demand. So we have own price to EPX to be proportionate change in QoS over proportionate change in DX. Okay. You know now, when we are dealing with elasticity, we have what? Q2 minus Q1 over P2 minus P1. But in demand estimation, or based on the elasticity approach we use in demand estimation, we don't use the Q2 minus Q1 over the P2 minus P1, but rather what? We differentiate the quantity function, the QDS function, with respect to what? Px, then we get what? The differentiated one. So it becomes QoS, differentiate QoS with respect to Px. Bracket. What's here moves up Px over QoS? So we are going to differentiate the quantity function with respect to what? Px. So we have that. So differentiate QoS. So we have minus 144 minus 2.5 plus 1.25 QoS plus 0.205 plus 0.068. We are going to differentiate QoS with respect to Px. So anything you see at this side or at this area, apart from Px, it's what? 0. So this is not Px, so this is what? 0. This is also not Px, so this is what? 0. This is also not Px, so 0. Same applies, to 0. So you are left with this IUP. So what next? You will then pick the coefficient of Px, or the number attached to what? Px is what? Negative 2.5. So our differentiate of QoS with respect to Px is what? Negative 2.5. So we now have this. All the Px in the question. Not the 40, but the actual, the new price 20. So we have Px 20. QoS 54. So we have this. We now have Px 20, QoS 54. You have the differentiated part of what? Minus 2.5. So minus 2.5 times Px 20 over QoS 54. We have minus 0.925. Okay. So in normal elasticity, this is supposed to be what? In elasticity is what? Less than 1. But when you are dealing with the own price in demand estimation or the elasticity in managerial economics, you always take absolute values of what? Our final answer. So this becomes absolute value EPX. That's what? Less than 1. So 0.925. So therefore, the demand curve is what? Inelastic. So basically with the G, estimate the own price elasticity of demand. That's how we do it. Are you okay? So moving on to the next one, which is what? The age. Okay, so with the age question, still a type of demand curve your firm would have. So since price elasticity of demand, what we did earlier on, we had what? Less than 0.93. It's equal to 0.93, less than 1. So we have what? Inelastic demand curve. Are you okay? So with the R, what would be the firm's price policy option? So that's how we do it. If your answer for the own price elasticity of demand was inelastic, if your answer for your own price elasticity of demand is inelastic, there will be an increase in price, which results in increase in total revenue. If the own price elasticity of demand question you solve, you had elastic. As your price increases, your total revenue increases. What would be the firm's price policy or pricing policy option? We use only this. If it's inelastic, increase in price increases total revenue. If it's elastic, increase in price decreases total revenue. So we have what? Inelastic. So what would be the firm's pricing policy? The pricing policy for the firm would be inelastic demand based on what? Increase in price leading to what? Increase in total revenue. So the demand curve. Since since the demand here is inelastic demand. The pricing policy option for the firm. So then, our own price was what? Inelastic. So we are going to use what? This one. We use the first one. So since the demand curve is inelastic demand, the pricing policy option for the firm will be an increase in price results to an increase in total revenue. That's for the I. So we are down with the I. We move on to the G. Okay, so with the J, assess the probable impact on your firm if Yaragan decreases the price of Asasura fertilizer by what? 8%. So with this side, it said assess the probable impact on your firm if Yaragan decreases the price of Asasura fertilizer. So with this side, we are trying to compare what? Asasura and what? Okay, assess the probable impact on your firm if Yara Ghana decreases the price of Asasura fertilizer. With Asasura, it was noted by what? They said price of Asasura fertilizer per bag is what? DY, which is this. This for Asasura. Then price of bedrock fertilizer per bag is this.
No. Give me something.
Fertilizer.
I bet it's like, yeah.
So, assess the probable impact on your firm. Yara Ghana decreases price of Asasura fertilizer by 8%. So you are going to calculate what the impact the decrease was for the 8% had on what? Asasura fertilizer. So with the Asasura fertilizer was noted by what? PY. Are you good? So with this, you're going to compare Asasura and what? Bedrock fertilizer. So basically, you're talking about what relationship between what? Bedrock fertilizer and what? Asasura. Are you good? So with that one, we use what? Cross elasticity. Remember, we have what? Circuit and what? Complement. So meaning that with this particular question, we are calculating for what? Cross price elasticity of demand. Someone can also say, okay, how do I also identify if I'm calculating for cross price elasticity of demand? They said Asasura fertilizer. That what was the leg that you noted for what? Asasura fertilizer. We had what? PY. Are you good? So meaning PY is a variable noted for what? Cross price elasticity of demand. Either PY or PZ. So you are calculating for what? Cross price elasticity of demand. So we have EXY because proportionally change in PY or proportionally change in PY. X cross, if you are picking a quantity, let's say cocoa, you are not supposed to pick that same price of cocoa, but you pick a different price of what? Let's say cassava. That's why you see Y here. But with their own price, if you are picking a quantity, let's say cowboy, you are supposed to pick the same price of cowboy. So with their own price, if this side is PO, this side is also what? PX. But with cross price, if this side is PO, you are not supposed to use the same price. That's why this side is for meaning price to other related goods. So here's why we have differentiate POS. You expect PY. Then you have PY equal POS. If you are going to differentiate POS, we respect to what? PY. So you pick the quantity, does it? So QS is equal to minus 144 minus 2.5 px plus 1.25 py plus 0.20 I plus 0.06 A. So we are going to differentiate QS with respect to what? Py. QS with respect to Py. So anything we see here apart from Py, it's 0. This is not Py, so it's 0. This is not Py, it's 0. This is also not Py, it's 0. 0. So let's for this. So then pick the coefficient of Py or the number attached towards Py, it was 1.25. So 1.25. It was for the differentiation of what? Q with respect to Py. So this is what 1.25. Previously we had price of Y to 40 cents. We have quantity to what? 54. So now we have Py, we have QS, we also have this to what? 1.2. So we substitute it into what? The equation, then we solve for what? The cross price. We have this 1.25 Py 40 QS 50. So we have this to what? The cost price elasticity of what? Demand. Are you good? This becomes what our cost price elasticity of demand. But they are saying that what? We should assess the space on what? The decrease in what? Price of what? Asasura fertilizer by 8%. Are you good? So meaning they are going to find how much the quantity that Asasura is selling. How is going to decrease by what? 8%. So we now have the same cost price EXY. Proportionate change in QS. Or proportionate change in what? PY. So with this, the EXY, that's what we have here. 0.925. So EXY, 0.925. Okay. You are finding for what? The impact on your firm. If Yara Ghana decreases their price of Asasura fertilizer by 8%, so with a percentage change in price was given as what? 8%, means was a decrease. So this is how we do. So we maintain this. Decrease what? Negative what? It's 8%. 8 divided by 100. 0%. So negative. So 0.08. Okay. So we are finding for this. So we have 0.925 times negative 0.08. So we will get this. So this is what? The quantity. So we want to find what? The decrease in percentage by what? 8%. So we then multiply this by what? 100. That becomes what? The decrease in percentage by what? 8%. So this times 100. So therefore, a decrease in price of Asasura by 8% would bedroom. So yeah, J, after this, how we calculate it. So first, you find the cost price. That's it. You differentiate KOS. You expect PY. You get 1.25. PY in our question was 40. KOS 54. We had just what? Cost price. IUP. Now, they were asking of what? A decrease. Sorry. If Yara Ghana decreases the price of Asasira fertilizer by 8%, meaning I should calculate for what? The decrease in what? Price. If decrease in price for what Asasira by what? 8%. So there's it. There's the actual one, negative 7.4. So a decrease in price of Asasira by 8% would lead to a decrease in quantity demand for bedrocks fertilizer. Actually, with the JDS how we do it. Okay, so with the key, interpret the adjusted R square. So based on the table, we gave it adjusted R square to what? 0.8947. So use the same format. This is how we interpret it. An adjusted R square of 0.8947 implies that all the explanatory variables explains less than 100%. It's 9 points. So an adjusted R square of 0.8947 implies that all the explanatory variables explain 89.47 of variations in the dependent variable. Okay, if it's R square, you end here. Here lies the case as what? Adjusted R square. So you are taking into consideration the sample size and this is how we interpret adjusted R square. Adjusted R square of 0.8947 implies that all the explanatory variables explains less than 89.47% of variation in the dependent variable, taking into consideration the sample size and the number of explanatory variables. We use this for adjusted R square. If it's R square, you end here. R square, you end here. This side, R square. Adjusted R square, we are taking into consideration the sample size and the number of explanatory variables. So basically, this was what? An example of what demand estimation question we just solved. So we'll try and solve a different one whereby we use the p values in our next video.